Mr. Harmless here, and we are going to take a look at the 30, 60, 90 special right triangle. And it's special because it only works with what I'm going to show you today, only works with a right triangle that has these three angles 30 degrees, 60 degrees, and 90 degrees. Notice that when we're looking at a triangle that looks like this, because these two angles that are not the right angle, because these two angles are not the same size, that means the legs are different sizes. The one that is opposite the 30-degree angle over here, I'm going to call it the short leg. I'm going to put SL for short leg. The leg that is opposite the 60-degree, I'm going to call it, and this is a real technical term, so follow closely. I'm going to call it the long leg, and let's use an LL to represent that. This other side here, opposite the right angle, is called, well, this hasn't changed. It's the hypotenuse. Okay. Now, I'm going to represent the short leg, whatever its length is, with the letter X. Let me switch colors here. Let me go to orange. So this X represents the length of the short leg. So I'm going to put an X up here. Now, there's a certain relationship between the short leg and the hypotenuse, and the short leg and the long leg. Notice the hypotenuse is longer than the short leg. The nice thing is it's exactly twice as long. Whatever the length of the short leg is, the hypotenuse is twice its length. So whatever the whatever the short leg is, we're going to just take that short leg times 2, and it's going to be the length of the hypotenuse. So go to x, right? So the hypotenuse would be 2x. So if the short leg is 5, the hypotenuse is 10. If the short leg is 12, hypotenuse is 24. If the hypotenuse is 30, the short leg would be 15. Okay, so that relationship never changed, no matter how big or large this triangle is. If it's a 30-degree, 60-degree, 90-degree right triangle, that means that the short leg and the hypotenuse, that's always the relationship. You could have a triangle that had a short leg the length of 26 light years. And you could figure out what the hypotenuse is, right? You just take 26 times 2, which would be 52. So it'd be 52 light years. So it doesn't matter how large this triangle is, that will always be the case. Now, the long leg is a little bit different, okay? Notice that the long leg, it's not as long as the hypotenuse. So I know that the long leg's not going to be twice the length of the short leg. It's got to be something smaller than 2, but it's also not the same length, so it's got to be bigger than 1. It's not 1 time bigger, and it's not 2 times bigger. It's something between the two. And it just so happens that the relationship between the short leg and the long leg is the square root of 3. So whatever the short leg is, if I multiply it by the square root of 3, I'm going to get the long leg. So I'm going to say x squared is 3. Okay? All right, so now that I have this information, now if you are a formula person, you could do this. You could say, well, the hypotenuse equals the short leg times 2. Or you could say the short leg equals the hypotenuse divided by 2. You could also have, since you have the long leg here, you could say the long leg equals the short leg times the square root of 3. Or you could say the short leg equals the long leg divided by the square root of 3. Okay? So if you're a formula person, you can try to memorize these, or you could just remember that there are 2 key numbers with the 30, 60, 90 triangle. One key number is the number 2. The other key number is the square root of 3. And you just have to remember which one goes with which relationship. Short leg to hypotenuse, 2. Short leg to long leg, square root of 3. Most students that struggle with this don't struggle because of the math. They struggle with just remembering which number goes with which. But let's put this into practice, okay? So let's switch to blue here. So I'm going to do this problem. So the first thing I do is identify if this is a 30, 60, 90 triangle. So I've got a 90 and a 60. If I do the math, I would figure out that's a 30-degree angle. Then I figure out what I'm looking at. Notice this 5 is the short leg. The x is the long leg. And the y is the hypotenuse. Now, if you're having trouble figuring out which one is which, I can help you with that a little bit separately. But the short leg is always opposite the 30 degree. But I always identify which one is the hypotenuse first. I always look for that right angle, and it's pointing at the hypotenuse, right? It's almost like it's an arrow pointing at the hypotenuse. Okay. You don't have to think of it that way, but I've noticed some people that tends to be helpful. So I've identified the parts. I know that the number I have is the short leg. So then I ask myself this question: well, what's the relationship between the short leg and the hypotenuse? And if I remember that, relationship is 2 between short leg and hypotenuse. So that means that it's double. So that means I can take 5 times 2 to get the hypotenuse. 5 times 2 equals 10. So the hypotenuse has a length of 10. Now the long leg and the short leg have a different relationship. Their relationship is the square root of 3. So the long leg is longer than the short leg, so I'm going to multiply, and since I know the relationship, square root of 3, I can take 5, the short leg, times the square root of 3. 5 times the square root of 3 is 5 square roots of 3. Okay? All right, now I'm going to skip this one for now. We have several examples here. This one's the same as that one. It gives us the short leg to start off with, but let's try one that starts with the hypotenuse. So notice this one here, and I'm going to switch colors again. Let's go brown. So this one here, I've got this 32. Okay, it is a 30, 60, 90 right triangle. This 32 right here is the hypotenuse. The x, since it's opposite the 30-degree angle, it's the smallest side. It's going to be the short leg. And the y is going to be the long leg. You have to make sure that you get this right. Sorry, a bit of an interruption there. So this one here, we've got the hypotenuse, we've got the short leg, we've got the long leg, and I got to think here. Now, I can't go directly from the hypotenuse to the long leg. I don't know that relationship. I know the hypotenuse and the short leg relationship is the number 2. So I could go, since I'm going from something larger to something smaller, I could do the hypotenuse divided by 2 to find the short leg. 32 divided by 2 is 16. So this is 16. Okay. Now that I have the short leg, I know the relationship between the short leg and the long leg is the square root of 3. Since it's going from something smaller to something larger, I know I'm going to multiply. So I'm going to do 16 times the square root of 3. 16 times the square root of 3 is 16 square roots of 3. Okay. Now I'm going to do one more example here, and the final example I'm going to do is this one right here, number 8. I might do number 9 as well, but let's definitely do number 8. This one is starting off with a long leg, and so I'm going to think about this here. I've got the long leg. I need to find the short leg, and hopefully you're getting better identifying these. Here's the hypotenuse. Okay, so once again, I don't know the relationship between the long leg and the hypotenuse, but I do know what it is between the long leg and the short leg, and it's the square root of 3. So I know I'm going to divide by the square root of 3. So I'm going to do 20 divided by the square root of 3. Now, if you already watched the 45, 45, 90 triangle lesson, then you know what you're supposed to do here. But in case you haven't, let's talk about it real quick. To get rid of the square root of 3 in the denominator, you're not allowed to have that, right? So I'm shifting out of geometry mode into algebra mode and thinking about how to simplify this fraction right here, right? 20 over the square root of 3. We learned in that first lesson that the way to get rid of a square root in the denominator is to multiply that top and the bottom by that same square root. So I'm going to multiply the top and the bottom by the square root of 3. Technically, I'm just multiplying by the number 1, right? Square root of 3 over square root of 3 is just 1. So I'm not changing the value here, because if you multiply something by 1, it doesn't change it. But it is going to look different. It's going to look different because the square root of 3 times the square root of 3 is just going to be the number 3. Right? If I take the square root of 3 and multiply by the square root of 3, square root of 3 times the square root of 3 is the square root of 9. And if you use your calculator, or if you have this one memorized, the square root of 9 is just 3. This works with any square roots. In the numerator, I have the 20 and the square root of 3, so I'm going to do 20 times the square root of 3. And so now I know that y is 20 square roots of 3 all over 3. Okay. Now I need to find the hypotenuse, okay? Now I know the short leg and the hypotenuse relationship is the number 2. And since I'm going from something smaller to something larger, I'm going to multiply by 2. So I'm going to take my short leg, I just figured out it's 20 squared roots of 3 over 3, and I'm going to multiply this by 2. Now when you're multiplying, right, this means this is the same thing as 2 over 1. So we're going to multiply straight across here. 20 squared roots of 3 times 2, 3 times 1. Well, 3 times 1 is just 3, so that's easy. Now, it doesn't matter what order you multiply in. So the 20 and the 2, I can go ahead and multiply those together, and I get 40. But I can't multiply a number outside of a radical with one inside, so I have to leave it like this, 40 squared roots of 3 over 3. And so that's what I get for the x, 40 squared roots of 3 over 3. Final question here. Once again, starting with the long leg, need to find the short leg, and I need to find the hypotenuse. Okay, these answers will look a little bit better than the last one. The way I do this, just like this one, if I have the long leg, I can't find the hypotenuse because I don't know that relationship, but I can find the short leg because I know that the relationship is the square root of 3. So I know I'm going to go from something larger to smaller, so I'm going to divide. So to go from the long leg to the short leg, I'm going to take the long leg, I'm going to divide it by the number, the square root of 3. Now this one's nice because since I have a square root of 3 in the numerator and the denominator, those can cancel. I end up with 9 over 1, which is just 9. So x equals 9. Now I can go to find, since I have this now as 9, now I can go to find the hypotenuse. And I know the relationship between the short leg and the hypotenuse is the number 2. So that means that I can take this short leg, multiply it by that relationship of 2. 9 times 2 is going to be my hypotenuse. 9 times 2 is 18. So that means that y equals 18. Well, I know that this might have been a little bit long. Hope that it was helpful. And if you have any other questions, let me know.